Hello friends, today I am going to discuss heights and distances from standard 10. Let us see practically in our day-to-day life how trigonometry helps us. Let us see how we can find the distance between two objects or the height of any object by using trigonometry and not by actual measurement. So let me share the screen. In this chapter, heights and distances, we will always deal with right-angled triangles. And the most important terms which we will come across any question related to heights and distances are angle of elevation and angle of depression. So in order to identify the angle of elevation, we have to first of all consider the eye of an observer on a horizontal line. Suppose O is the eye of an observer here and the observer is watching something above the line, horizontal line OX, say P. So when the observer is looking up, then the line joining the object to the eye of an observer will make an angle with the horizontal line. So this angle theta will be termed as the angle of elevation. Suppose again from a horizontal line, an observer is looking below. So here O is the eye of an observer here, right? And the observer is looking below to some object here. So OX is the horizontal line and the line joining the eye of an observer to the object P will make an angle theta with the horizontal. That means the observer is looking down. So this angle theta will be known as the angle of depression. So whenever we read a question related to the chapter heights and distances, we have to mark the word elevation or depression, and accordingly we have to draw diagrams which will always give you right angle triangles. One more important thing to be remembered in this chapter is the value of root over 2 and root over 3, which will be most often used to solve questions. So an aeroplane, when flying at a height of 3,125 meters from a ground, passes vertically below another plane at an instant when the angle of elevation of the two planes from the same point on the ground are 30 degree and 60 degree respectively. Find the distance between the two planes at that instant. So here you have to read the question and draw the diagram accordingly. So I will consider A1 as the position of the aeroplane below another aeroplane A2. Now the angle of elevations of the two planes at an instant are 30 degree and 60 degree from the ground. So suppose we have the ground over here and an observer is looking at both the planes from the same point. And I'm also drawing the perpendicular distance of the two planes from the ground. So this point, if we complete the triangle here, this point O is the observer looking at aeroplane A1 making an angle of 30 degree as the angle of elevation, and he is also looking at another aeroplane making an angle of elevation of 60 degree. So now GO is the ground, suppose. We have to find the distance between the two planes, that is we have to find A1, A2. So here in this figure, we observe that there are two right angle triangles, and the two right angle triangles are A2GO and A1GO. Now, as we are concerned about A1, A2, that is a part of the perpendicular distance from the ground, so we will consider ratio of the two sides, that is the base and the perpendicular. Hence, we will deal with tan 60 degree for this triangle and tan 30 degree for the other triangle. So tan 60 degree is perpendicular by base, so A2G by GO, and tan 30 degree is also perpendicular by base, so this is A1G by GO. So here tan 60 degree means root over of 3. A1G is given as 3125 meter. A2G is not known. So A2G can be written as A2A1 plus A1G. Right. And so what is the value of OG here? Value of OG will be A2A1 plus 3125 meter. A1G will be 3125 by root over of 3. Next, for the other triangle, tan 30 is 1 by root 3, A1G is 3125 by OG. So OG in this case will be root over of 3 into 3125. So I am marking this as equation 1 and marking this as equation 2. Since both these values are equal to OG, so from 1 and 2 we have root over of 3 into 3125 equals to A2A1 plus 3125 by root over of 3. When we cross multiply, we have 3 into 3125 equals to A2A1 plus 3125 meter. Now, if we simplify this further, we have A2A1 equals to 9375 minus 3125. Which is equal to 6250 meter. So the two planes are at a distance of 6250 meter from one another at that instant. This question is, a man observes the angle of elevation of the top of a building to be 30 degree. He walks towards it in a horizontal line through its base. On covering 60 meter, the angle of elevation changes to 60 degree. Find the height of the building correct to the nearest meter. So we have to first of all consider a horizontal line, that is the ground. We have a building also here perpendicular to the ground, and the observer is here, suppose, looking at the top of the building, making an angle of elevation of 30 degree. Now he is walking towards it, means walking towards the building, right? And suppose reaches the point B, which is equal to 60 meter, on covering 60 meter. So this is 60 meter. And from the point B, he is again looking at the top of the building. So here PL is the building, suppose, and this is a right angle triangle PLB, and the other right angle triangle is PLA. So here in this diagram we again have two right angle triangles, PLB and PLA. Point B and looking to the top of the building P, the angle of elevation is given to be 60 degrees. So now we have two right angle triangles here, PLB and PLA. We need to find the height of the building, that is PL. Let us consider BL as X. Now, since we need the perpendicular distance and the base is given as X plus 60 meter, so we can consider the ratio of these two sides, and for triangle PLB we can write tan 60 degree equals to PL by LB, and LB we have considered X, so PL by X equals to root over of 3. So X can be considered as PL by root over of 3. In the next right angle triangle, that is triangle PLA, we have tan 30 degree equals to PL by LA. Now LA can be written as LB plus BA. Now LB is of length X meter, BA is of length 60 meter, and tan 30 degree is 1 by root over of 3. So 1 by root over of 3 into X plus 60 equals to PL. The value of X can be substituted from equation 1 here. So this is PL by root over of 3 plus 60 equals to PL. Now simplification gives PL by 3 plus 60 by root over of 3 equals to PL. This gives 60 by root over of 3 equals to PL minus 1 by 3 PL. On taking PL as the common factor out, we have 1 minus 1 by 3. That gives 2 by 3 into PL. So PL equals to now 60 into 3 by 2 root 3. If we rationalize the denominator, we have 30 into 3 root 3 by 3. That gives 30 into root over of 3. The value of root over of 3 is 1.732. We should never keep our answers in root over form. So we have to substitute the value of root over 3 as 1.732. This multiplication gives 51.96 meter. But the question says find the height of the building correct to the nearest meter. So we have to give a whole number as the answer. So 0.96 meter can be considered as 1 meter. So 52 meter finally is the answer. The next question is the horizontal distance between two towers is 140 meter. The angle of elevation of the top of the first tower when seen from the top of the second tower is 30 degree. If the height of the second tower is 60 meter, find the height of the first tower. So we have two towers at a distance of 140 meter. So this is the horizontal plane and we have two towers perpendicular to the plane always. Now one longer than the other. So here the distance between the two towers is 140 meter and the angle of elevation of the top of the first tower when seen from the second tower. So you are looking from B to the point C, and the angle of elevation of the top is said to be 30 degree. So we have the horizontal plane again over here, so that we get the angle of elevation as 30 degree here. That is angle CBD is 30 degree. Next, if the height of the second tower is 60 meters, so this is the second tower, 60 meter, find the height of the first tower. So we have to find out CT, and we are given the height of AB as 60 meter. So since TA and DB are equal in length, so DB will also be 140 meter, and TD equal to AB, so TD will be equal to 60 meter. As this angle T is 90 degree, angle A is 90 degree, also angle D over here, that is angle TDB, equal to 90 degree. So we can consider DTAB to be a rectangle, and the opposite sides of the rectangle are equal, so equal measurement for the opposite sides. Now we have to find the height of the first tower, that is we have to find CT. Now again over here we have the right angle triangle CDB. So we have only one right angle triangle CDB here, right? So we need CD, because DT is already known. If we can find out CD, our work is done. So CD is the perpendicular, DB, that is 140 meter, is the base. So we need the ratio between the base and the perpendicular to be written as tan 30 degree equals to CD by DB. Tan 30 degree means 1 by root over of 3. CD value not known, but DB is 140 meter. So CD equals to 140 by root over of 3. Let us rationalize the denominator. So this gives 140 by 3 root 3. So 140 by 3 into 1.732, this gives 80.829 meter. Therefore CT will be 80.829 meter plus 60 meter, giving us 140.83 meter. So this is the final answer. Question is, the angle of depression of two ships A and B as observed from the top of a lighthouse 60 meter high are 60 degree and 45 degree respectively. If the two ships are on the opposite sides of the lighthouse, find the distance between the two ships. Give your answer correct to the nearest whole number. So you have a lighthouse which is 60 meter high, and you have the sea level. So this is the sea level, this is the lighthouse, and there are two ships on two different sides of the lighthouse. So suppose this is the lighthouse. S1 and S2 are the two ships, and the angle of depression of the two ships as observed from the top of the lighthouse. So we need a horizontal line passing through L, right? Now when we are looking down from L to S1, and then from L to S2, the angle of depressions are 45 degree here and 60 degree here. So this angle XLS1 angle XLS1 is equal to angle LS1H, both being alternate angles, and angle YLS2 is equal to LS2H, both being alternate angles. So here this is 45 degree and this is 60 degree. The height of the lighthouse is 60 meter. We have to find the distance between the two ships, that is S1, S2, to be found out. Now in this diagram we can see two right angle triangles, right, and we need to find the length of S1, S2, that is the base of the right angle triangle. The perpendicular is given, the base to be found out. So we will go for tan 45 degree and tan 60 degree. So in triangle LS1H, tan 45 degree equals to LH by S1H. Tan 45 degree is 1. So LH by S1H will be equal in length. Now this is equation 1. In the other right angle triangle, that is in triangle LHS2, we have tan 60 degree equals to LH by S2H. Tan 60 degree is root over of 3 and LH is 60 meter. So here in equation 1 also we can write S1H is 60 meter. Now S2H to be found out. So S2H is 60 by root over of 3 meter. Let us rationalize the denominator. So here it is 60 by 3 into root over 3, that gives us 20 root 3. So this is 20 into 1.732, which is equal to 34.64 meter. Therefore, S1, S2 equals to S1H plus HS2, that is 60 plus 34.64, giving us 94.64, which is equal to 95 meter. We have to give a whole number as the answer because the question says to the nearest whole number. Give your answer correct to the nearest whole number. The next question is, a man 1.8 meter high stands at a distance of 3.6 meter from a lamppost and casts a shadow of 5.4 meter on the ground. Find the height of the lamppost. So here the observer is not a point object, but the height of the observer is given here. So unlike the previous questions, we have the height of the man also. Suppose this is the ground and this is the lamppost and this is the height of the man standing in front of the lamppost, and the shadow of the man will be on the left side here. So this is the lamppost, this is the man, and SA is the shadow of the man. So height of the man is 1.8 meter. Lamppost is at a distance of 3.6 meter from the man, and the shadow of 5.4 meter length. 5.4 meter. Find the height of the lamppost. So we have to find LP. Let us consider angle S as theta. In this diagram again we have two right angle triangles. One is triangle MSA and the other is triangle LSP. So in triangle MSA, tan theta equals to MA by SA. So MA is 1.8, SA is 5.4. 4. Let us leave the value of tan theta in this way only. This is equation 1. And in the other triangle, that is triangle LSP, we have tan theta equals to LP by SP. Value of tan theta can be substituted from equation 1 as 1.8 by 5.4. LP is to be found out and SP is 5.4 plus 3.6 meter. 18 by 54 equals to LP by 9. So LP equals to 18 into 9 by 54, which is equal to 3 meter. So height of the lamppost is 3 meter. So this length is 3 meter. The next question is, the angle of depression of the top and bottom of a 8 meter tall building from the top of a multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. Correct to the 2 decimal places. So we have a multi-storied building and we have another tall building of 8 meter height. This is the ground and the buildings naturally will be perpendicular to the ground. Now the angle of depression of the top and bottom of the 8 meter tall building. So you are looking from the top of the multi-storied building to the 8 meter tall building top and bottom. So we are looking down to this. Now here the angle of depressions are 30 degree and 45 degree, right? So if the building is multi-storied building is BL and the shorter building is CD, which is 8 meter, then angle XBC, that is 30 degree, should be equal to angle BCA. Suppose now what is A here? We have to draw a line parallel to the ground so that we have the point A here. Now showing the angle of depression is a must to fetch full marks for this question. Next, angle XBD is 45 degree, which is equal to angle BDL, both being alternate angles. So this is 45 and this is 30 degree. Now again in this diagram we have two right angle triangles. Now we are supposed to find the height of the multi-storied building correct to 2 decimal places. So to find BL. Now about the two right angle triangles first. Triangle BDL tan 45 degree equals to BL by DL. Now tan 45 degree means 1. So BL and DL are equal in length. Suppose both are of measure X meter. So I am writing here X and the total length of BL is also X. Next, in triangle BCA, tan 30 degree equals to BA by CA. Tan 30 degree means 1 by root over of 3. BA is not known but CA is X. So BA equals to X by root over of 3. Now over here again we have to note that this is 90 degree and this whole angle D is 90 degree here. This angle CAL is also 90 degree. So CDLA is a rectangle. Hence CD and AL are equal in length. So AL will be 8 meter. So BA will be x minus 8 meter. Right. So I am substituting the value of BA as x minus 8, which is equals to x by root 3. Let us find out the value of x now. So this gives root 3 into x minus 8 equals to x. So this is root 3x minus 8 root 3 equals to x. This gives root 3 minus 1 into x equals to 8 root 3. So x equals to 8 root 3 by root 3 minus 1. Let us rationalize the denominator. So finally I am writing here. So x equals to 8 root over 3 into root over of 3 plus 1, that is root over of 3 minus 1 into root over of 3 plus 1, that is a plus b into a minus b formula used here. So 3 minus 1 gives into 3 plus 8 root 3, that gives 24 by 2 . So this gives 8 root 3 into 1.73. Achha. Oh. 8 root 3 into root 3 plus 1 divided by 2, that is 4 root 3 into root 3 plus 1, that gives 4 into 3 plus 4 root 3, that is 12 plus 4 into 1.732, 12 plus 6.928, that is 18.928. Now we have to give our answer correct to 2 decimal places. So this is equal to 18.93 meter. So height of the multi-storied building and the distance between the two buildings, both are x. So height of the multi-storied building is 18.93 meter, and that of the distance between the two buildings is also 18.93 meter. So these are the two answers. The next question is, a vertical pole and a vertical tower are on the same level ground. From the top of the pole, the angle of elevation of the top of the tower is 60 degree and the angle of depression of the foot of the tower is 30 degree. Find the height of the tower if the height of the pole is 20 meter. So we have a tower and we have a pole, both on the same ground. So from the top of the pole, we are looking to the top of the tower and we are also looking to the foot of the tower. So since there is an angle of depression, I need a line parallel to the ground. So we are looking up and looking down. When we are looking down, the angle of depression is said to be 30 degree, and when you are looking up to the top of the tower, the angle of elevation is said to be 60 degree. So PL is the pole and TW is the tower and PA is the line parallel to the ground. So here it is said that the height of the pole is 20 meter. We have to find the height of the tower. Now again, angle L here is 90 degree. The whole of angle W is 90 degree. Here angle PAW is also 90 degree. Therefore PLWA is a rectangle. So PL equals to AW equals to 20 meter. Opposite sides of the rectangle are equal. Now again in this diagram we have two right angle triangles. You can see here that angle APW equals to 30 degree, which is equal to angle PWL, both being alternate angles. So this is also 30 degree. Now the two right angle triangles to be considered here are triangle PLW and triangle TPA. So in triangle PLW we have tan 30 degree equals to PL by LW. Right, so tan 30 degree is 1 by root over of 3. PL is 20 meter, LW is not known. So the value of LW will be 20 root 3. LW is also equal to PA. So PA is also 20 root 3. Let this be equation 1. Next, in triangle TPA, tan 60 degree equals to TA by PA. Tan 60 degree is root over of 3. TA is not known and PA is 20 root 3. So the length of TA is 20 root 3 into 3, that is into root 3. 20 root 3 into root 3, that is 20 into 3 equal to 60 meter. So, hence the height of the tower TW equals to TA plus AW, that is 60 meter plus 20 meter, which is equal to 80 meter. This is the answer. Next question is, an aircraft is flying at a constant height with a speed of 360 km per hour. From a point on the ground, the angle of elevation of the aircraft at an instant was observed to be 45 degree. After 20 seconds, the angle of elevation was observed to be 30 degree. Determine the height at which the aircraft is flying. Suppose A is the position of the aircraft and it is flying at a speed of 360 km per hour. From a point on the ground, the angle of elevation of the aircraft at an instant was observed to be 45 degrees. So we need the ground here, right? And from this point on the ground, we are looking up to the aircraft at an instant where the angle of elevation is 45 degree. So this point is O for the observer. After 20 seconds, the angle of elevation was observed to be 30 degree. Now after 20 seconds, let B be the position of the aircraft. So for 20 seconds, it has traveled and reached the position B. Now from the same point O on the ground, if you look at the aircraft at the point B, the angle of elevation is said to be 30 degree. Right, this is 30 degree. We have to find the height at which the aircraft is flying. So we need to find this perpendicular distance, which is same as this distance because it is flying at a constant height. So let me name this as CD. Now speed is 360 km per hour and it is traveling for 20 seconds suppose, which is equal to 20 by 3600 hours. Now the distance covered equals to speed into time. So it is 360 km per hour into 20 by 3600 hours. So here this cancels and it is 2 kilometers. So 2 kilometer distance traveled from A to B. So CD is also 2 kilometer because ACDB is a rectangle. We have to find the height of BD. Now here in this diagram we again have two right angle triangles, that is triangle AOC and triangle BOD. In triangle AOC, tan 45 degree equals to AC by CO. So tan 45 degree means 1. So 1 equals to AC by CO, which implies AC and CO are equal in length. And let me consider this as X. Okay, this is equation 1. So here it is X. Now in triangle BOD, we have tan 30 degree equals to BD by OD. Tan 30 is 1 by root over of 3. BD and AC are equal in length, so it is X, and OD is X plus 2. So let us find out the value of X now. So X plus 2 equals to root over of 3X. This gives 2 equals to root over of 3 minus 1 into X. Therefore, X equals to 2 by root over of 3 minus 1. Simplifying over here, so we have X equals to 2 by root over of 3 minus 1. Rationalizing the denominator, we have this. Now 2 by root over of 3 plus 1 divided by 2, that gives us root over of 3 plus 1. So which is 1.732 plus 1, that is 2.732 kilometer, or it can also be said as 2732 meters. So this is the height of the aircraft. The next question is, a man standing on the deck of a ship which is 20 meters above the sea level observes the angle of elevation of a bird as 30 degree and the angle of depression of its reflection in the sea as 60 degree. Find the height of the bird. So this is an interesting question here. We have the sea level here, and at some height we have the deck of the ship. Right? Suppose this is the height of the deck of the ship. Now this height is said to be 20 meter. Right? Now, and this is the level of sea water. Now a bird is somewhere here, suppose, and a man is standing here and observing the bird at an angle of 30 degrees. So angle of elevation of the bird from here is 30 degree. Now the angle of depression of its reflection in the sea is 60 degree. So now the reflection of the bird is there in the sea. If this level of sea water acts as the mirror, then the image distance and the object distance has to be the same. So this distance will be equal to this distance. So here the man is looking at its reflection in the water and the angle of depression is said to be 60 degree. So B is the bird and R is the reflection of the bird. EF is the deck of the ship, which is equal to the length MN, because MNFE is a rectangle here, right? Now here, since NF is the mirror line, we have to keep in mind that BF equal to RF. Okay, and BF is 20 plus BE, which is equal to RF. Now we have to find BE. Now here in the diagram you can see two right angle triangles. The first right angle triangle is triangle MEB. In triangle MEB, tan 30 degree equals to perpendicular by base. So BE by ME. So this gives 1 by root over of 3 equals to BE by ME. So ME can be written as root over of 3 BE. This is equation 1. Next, in triangle REM, tan 60 degree equals to perpendicular by base. So here RE is the perpendicular, ME is the base, and RE can be written as 20 plus RF, and ME can be written as root 3 BE from 1, and tan 60 degree means root over of 3. Next, here root over of 3 equals to 20 plus. Please note that RF is 20 plus BE. So RF is replaced by 20 plus BE. It is over here I have shown. So from the asterisk sign, from this part, divided by root over of 3 BE. Cross multiplication gives 3 BE equals to 40 plus BE. So 2 BE equals to 40. Therefore, BE equals to 20 meter. So BE comes as total of 20 meter. Hence, the height of the bird from the deck of the ship is 20 meter. And the height of the bird from the sea level is 20 meter plus 20 meter. That is BE plus EF, which is equal to 40 meter. So if we find the height of the bird from the deck of the ship, it is 20 meter, and from the sea level it is 40 meters. So we can consider this as the answer. So this much for today. Thank you for watching. Take care. Good day.